Hello everybody, today we will be entering chapter 3, which is on dynamics of linear motion. So in this chapter there are 4 subtopics, and the first one is momentum and impulse. So in this subtopic you have to be able to define what is momentum and what is impulse, solve problems related to impulse and impulse momentum theorem, so it applies only for one dimensions, and lastly you have to be able to use the graph of force against time to determine the impulse. Alright, so momentum is defined as the product of its mass and velocity. So it has the symbol P, and it has the SI unit of kilogram meter per second ataupun Newton second. So please remember that momentum is a vector quantity, so it has both magnitude and direction lah, and the direction follows the velocity. Okay, so if the velocity is going to the right, the momentum would also be going to the right. So please note that the momentum vector can be resolved into its x and y component since it is a vector quantity. Okay, so please also remember that the momentum has the same direction as the velocity. Okay, so this is how you calculate the magnitude, and this is the direction. Okay, so basically an object that has a much greater momentum will be much harder to stop, and the effect that it will cause to another object if it is brought to rest by striking at the object will be bigger lah, right? And then we have impulse with the symbol J. So this one is defined as the product of force and time interval. So this is the formula. Dah lurus. And astaga. It is a vector quantity, and its direction is the same as the constant force acting on the object. If a single force acts on an object, the equation can be written as shown here. So basically, the impulse is the rate of change of momentum. Impulse is equal to the change of momentum. Okay, so the change in an object's momentum divided by the elapsed time is equal to the net force. Okay, so basically the rate of change of momentum is equal to the net force. Okay, so when two objects collide, they will exert large forces on one another for a short period of time. Okay, so for example, if there's two balls colliding with each other, both of these will exert large forces on each other for a short period of time. We can call it delta T. Okay, so forces of this type only exist for a very short period of time during collision, in which we call impulsive force. Okay, so impulse force against time force graph is shown here. So basically this shaded region is equal to impulse. Okay, so the area under this graph is impulse. Okay, that is the theory part for our first subtopic. Now we will go into the example. Oh, forgot to clear this. Okay, so for the first example, a 1.5 kilogram ball. So we have the mass, which is 1.5 kilogram, and it has an initial velocity of 40 meter per second, and the angle is 30 degree to the horizontal. So we have to calculate the momentum of the ball as well as the horizontal and vertical components of the momentum. So momentum is equal to mass times velocity, in which for this case we are given the question gives us the initial velocity, so basically this is just equal to this lah. Okay, so momentum is 1.5 multiplied with the velocity, which is 40, and we will get 60 kilogram meter per second ataupun Newton second, or 60 Newton second. Okay, and we have to calculate the horizontal and vertical component. So horizontal component is P cos theta. Why is it cos theta? Because the angle is to the horizontal line, and we are looking at the horizontal line. So this is gonna be equal to 60 cosine 30 degree. So we will get 51.96 kilogram meter per second, and the vertical component is P sine theta. So this is C sine 30 degree. So we will get 30 kilogram meter per second. Okay, so that is the solution for example number 1. Example number 2, 8.2 kilogram tennis ball strikes the wall horizontally with a speed of 100 meter per second, and it bounces off with a speed of 70 meter per second in the opposite direction. So basically there's a wall and a ball is here. The ball is here, so it strikes this wall and then it bounces off from the wall in the opposite direction. So this is this is 100 meter per second. So my sign convention is to the right is positive, to the left will be negative. And then for this velocity here, it will be negative 70 meter per second because it is pointing to the left. So we have to calculate the magnitude of impulse delivered to the ball by the wall. So impulse is equal to delta P ataupun F lambda T, if I'm not mistaken. Is that the correct answer? Is correct solution? No, F delta T lah, darat delta T. Sorry everybody. So force times dengan the time. But now we are only given the mass of the ball and the velocity. So we are gonna use the change of momentum. So that is mv minus u. So we have m equal to 0.2 kilogram times with final velocity, which is negative 70 minus 100. So we have the answer to be equal to negative 34 Newton second. So that is the impulse. Next, we have to calculate the question B. So if the ball is in contact with the wall for 10 milliseconds, we have to determine the magnitude of average force exerted by the wall on the ball. So we are then gonna use the impulse formula for the average force lah. Okay, so impulse is 34, and this is gonna be equal FAV. dt is 10 milliseconds. So we have the force to be equal to 3,400 Newton. Okay, so that is the solution for example number 2.